Hello everyone and welcome. Have you ever wondered how different parts of a large molecule can influence each other, almost like they're communicating from a distance? Today, we are going to explore a fascinating concept that explains this, the field effect in organic chemistry. It's an electronic effect, but it works in a very unique way. Let's break it down. The field effect is the electrostatic influence of one part of a molecule on another part, transmitted directly through space, not through the chemical bonds. Think of it like two magnets. They don't need to be touching to attract or repel each other. Their magnetic fields interact through the space between them. The field effect is similar. A polar group or a charged atom in a molecule creates an electric field around it. This field can then affect the electrons and atoms in another region of the same molecule. Now, this is very different from the more commonly known inductive effect. The inductive effect is transmitted through the sigma bonds of a molecule. Imagine a chain of people passing a message. The message gets weaker as it goes down the line. That's the inductive effect. The field effect, however, skips the chain entirely and sends the message directly through space. The strength of the field effect depends heavily on the geometry of the molecule and the distance between the interacting groups. A perfect example to understand this is comparing the acidity of two isomers, maleic acid and fumaric acid. Both have two carboxylic acid groups. In maleic acid, the two groups are on the same side of a double bond, so they are close together. In fumaric acid, they are on opposite sides, so they are far apart. When the first proton is removed from maleic acid, it forms a negatively charged carboxylate ion. This negative charge is very close to the second carboxylic acid group. Through the field effect, this negative charge electrostatically stabilizes the nearby proton on the second group, making it much harder to remove. In fumaric acid, the negative charge from the first deprotonation is very far away. Its through-space field effect on the second proton is extremely weak. Therefore, the second proton on fumaric acid is much easier to remove than the second proton on maleic acid. This shows how molecular shape directly impacts chemical properties through this through-space interaction. So, in summary, the field effect is an electrostatic influence that operates through space, is highly dependent on distance and molecular geometry, and is distinct from the through-bond inductive effect. It's a key principle that helps us understand why molecules with the same formula but different shapes can have vastly different chemical behaviors. Thank you so much for watching. If you found this explanation helpful and want to see more chemistry concepts broken down, please consider liking this video and subscribing. Your support helps the channel grow and allows me to create more content for you. See you in the next video.